Okay, let's look at this one. This is another derivative. The function is the square root of 3x plus 1 over x plus 2. So the first thing that we want to do is we'd want to think of this as 3x plus 1 over x plus 2 raised to the 1/2 power. So if I identify, oops, there we go. If I identify the outside function would be stuff to the 1/2. The inside function is going to be 3x plus 1 over x plus 2. So this example is really identical to the first example because I just have like a power rule, and then inside that I have a quotient rule. However, I wanted to show this one because the simplifying can get kind of messy. So that's the main reason what I really want to focus on this part. So the first step of getting f prime, I'm going to differentiate the outside function first. So I'm going to bring this 1/2 down in front and then subtract 1. So I'm going to have 1/2 times the inside function to the negative 1/2, and then times, and then this is all the derivative of the inside. So once again, that's a quotient rule, low d high minus high d low all over low squared. So now this next step is the same as the previous example. I've distributed the 3 here, and then here I've distributed through the negative to get 3x plus 6 minus 3x minus 1 over the x plus 2 squared. Once you combine your like terms in that second set of parentheses, you then have 1/2 times 3x plus 1 over x plus 2 to the negative 1/2, and that's just being multiplied by 5 over x plus 2 squared. Now, the problem is, because this fraction right here, the fraction as a whole is raised to the negative 1/2. So really the easiest way in order for me to simplify and get things where they belong is to break that up and take both the numerator to the 1/2 and the denominator to the 1/2. So if I do that, let me explain this step. If I do that, what I've done is I've taken 5 times the 1, which has given me 5, times, and then I've broken this parenthesis here, this fraction up, into 3x plus 1 to the negative 1/2, and then it's over, right here you see the x plus 2 to the negative 1/2 as well. And then I also still have down in the denominator the 2 times, and then this x plus 2 squared. So now that they are separated, I notice in the denominator what I actually have is I have like bases. So when I multiply like bases, I add exponents. So then that would be x plus 2 to the negative 1/2 plus 2 is going to give me a positive 3/2. And then that 3x plus 1 that's raised to the negative 1/2 can be moved to the denominator. So I end up with 5 over 2 times x plus 2 to the 3/2 times 3x plus 1 to the 1/2.